All right, so we're on page 213A. We're looking to simplify. What kind of a problem is this? What am I going to have to use to simplify this? What? PEMDAS, right. So PEMDAS is please excuse my dear. This is left to right. Aunt Sally, left to right. Okay. So do I have any parentheses here where I can do the work inside the parentheses? Well, of course I do. It's right here. So 7 minus 5 gives me 2. The rest of it you really should leave as it is. You can put that in parentheses, put the 4 on the outside, brackets, minus 3 squared. Whoever's got the music on, turn it off. Alex, please take that out. Just take it out. Everybody, take off your headphones, all things out. Put your hoods down. Earphones, please take them off. Kevin, you put them off. Ranisha, need your earbuds. Micah, earbuds out. I'm just tired of it. Taking them out. Thank you. Jesus, take the music, everything out, off. Everything out and off. All right. So here, I don't have any more parentheses. What would I do next? Exponents. I do have an exponent. So that's going to be right here. 3 squared is how much? 9. Okay, so put the bracket there, the subtraction in front. We got 4 times 2 in front of that, plus 10 divided by 5. Okay, what do I do next? Jesus, you asked about this one, right? So I've used my exponents. I've done the parentheses initially. Multiplication, division from left to right. 4 times 2. And that's going to give me 8. That's inside brackets. Minus 9 plus 10 divided by 5. Okay. All right. Now, I've got brackets, and I have some addition. I've got brackets, addition, and division. So what should you do next here? The brackets, because the brackets really are like parentheses, okay? So let's take 8 minus 9. That gives me negative 1. Put the rest of it together. I have negative 1 plus 10 divided by 5. What would I do next? Divide. 10 divided by 5 is 2. Negative 1 plus 2 gives me positive 1. All that for 1? Yes, all that for 1. Okay? But there's only one correct answer, and in this case it is 1. So doing things in the correct order does matter. I mean, you wouldn't put your pants on before you put on, well, maybe you would. I was going to say your socks, but people probably put pants on before socks. No? Okay. I was going to say your undergarments. You wouldn't put your pants on before you put your undergarments on, right? So order does matter. All right. Any other questions before we hit the circles hard? Yeah. 12A. 12A. Okay. Did we not do 12A? I guess I did in some other classes. Okay, use factor by grouping to factor and be sure to show all work. So we are factoring. We're not solving, we're just factoring. We did do 12A? Were you absent?
No. I thought everything was
Okay, I'll do it really quickly. So you separate it into two things, two separate halves. First two and then the last two. And then you're looking for your greatest common factor. So for the first two, for 2 and a 4, that's going to be 2. X to the 4th and x to the 3rd is going to be the smallest of those, which is x to the 3rd. That's my greatest common factor, which means that's what I'm dividing by here. So 2 divided by 2 simplifies out. X to the 4th divided by x to the 3rd. When you divide and have the same base, you subtract. So that is x is what is left there, minus 4 divided by 2 is 2, and x to the 3rd divided by x to the 3rd simplifies out. Same page, page 2. So then for the next one, I'm looking again for greatest common factor. That is between 3, 6 and negative 6, 3x, sorry, and negative 6. Greatest common factor there would be 3. So that's a positive 3, so I put the plus there. So I factor out the 3 out front. And what I have left from factoring, the 3 divided by 3 simplifies out. I have x minus, and 6 divided by 3 is 2. So I get 2x to the 3rd times x minus 2 plus 3 times x minus 2. This x minus 2 is common to both. So I'm going to now factor that out front. And what do I have left? My leftovers, as I used to say, is 2x to the 3rd plus that 3. And that is your final answer. But what's really important is you want to get that same factor from the first two terms and the last two, and then factor that out front. Okay? All right, let's go to page 3. And let's talk about circles. Some of these we may have done. So you need to tell me, because I've done different things for every class. Did we do number 1 in this class? No? Number 1 we did not do in this class? We did. How about number 2? We did 2? We did do 1 or we did not? How many say we did do 1? Okay. So we did 1, we did 2. How about 3? No? Okay. Radius of a circle. This is page 3. For those of you in our listening audience. Page 3, number 3. The radius of a circle is 6 centimeters. Radius is 6 centimeters. What equation would be used to find the circumference, given that we're using the radius? Survey says, anyone? For circumference, what would I use? C equals 2 pi r. Someone let Desiree in, please. Thank you. All right. So C equals 2 pi r. Then it says find the circumference of the circle, round to the nearest hundredth. So C equals 2 times pi. Pi is a number. That's a button on your calculator. Times r. What does r stand for? And radius is what? 6. Yes, they give that to you. So multiply on your calculator 2 times pi times 6 and give me 3 decimals.
37.699.
0.99. Now, they say round to the nearest hundredth. Which number is in the hundredth place?
9.
Which one?
The second.
The second one? Or in the second position?
In the second position.
Yes. So this is the hundredths place. Just put it on the far corner of my desk. Perfect. Look next door, 5 or more, that's going to go up. So sometimes it's a little tricky when it's a 9, but think of it this way and look at the whole number to the right. It was 69. If you add 1 to 69, it's going to be 70. So my answer is 37.70 in centimeters squared, cubed, or linear.
Cube.
No, that would be volume.
Square.
No, because circumference is just distance around the circle. So it is 37.70 centimeters. It says page 3. All right. How about number 4? Did we do number 4? Probably not. So angle 1 of this circle below is an example of what type of angle? I feel like Ken Jennings of Master Jeopardy. I've been watching that. Angle 1 is an example of what type of angle? Inscribed. That is correct. Inscribed angles have their vertex, the place where the two line segments that make up the angle are on the circle. So the vertex is on the circle. And what is the measure of angle 1 if the arc that it's intercepting is 128?
128.
It is not 128. What do you got? A bonus for me?
Yes, ma'am.
Okay. Well, you lie like a rug. No. Thank you.
234.
No.
64.
64 is correct. 64. So when you have an inscribed angle, it is going to be half of, or the arc degree divided by 2. So either half of 128 gives you 64, or you can say 128 divided by 2 equals 64. And when you think about it, look at that angle. It is much smaller than the arc that it is intercepting, right? Yes. Nope, because I'm doing circles right now. Sorry. So measure of angle 1 is 64 degrees. Okay, so let's go to the next page. Page 4 says, for number 5, we're on page 4, number 5, line segment KM is a diameter for the circle shown below. What is the measure of angle L? Well, question. What is the measurement of this arc? What's the degrees in the arc that I have in red up there? 180. It is 180. Very good. And we just said, if I look at this as angle L, what kind of an angle is that?
Obtuse.
No.
Cube.
No. Yes, but more than a right angle, it's an inscribed angle, right? So if this is 180 degrees, this angle that it intercepts with is going to be half of that. So that is why it is 90 degrees. Okay, 90 degrees. So if that's 90 degrees, that means the measure of angle K, right here, this angle, and the measure of angle M are going to be equal to what? This is what you have to know. How many degrees are in a triangle? How many degrees are in a triangle? 180. So if 90 of them are made by that one large angle, what must the addition of the other two be? Listen to the question. If this is 90 degrees, what must both of the others together add up to? 90 degrees. Yes. And they're not necessarily the same, Jesus. Okay? They do add up to 90 though. All right, so it says solve for x. Come on. Solve for x. Well, we have to add the measure of angle K plus the measure of angle M. So that is 9x minus 8 plus 8x minus 4 equals 90. All right, what do I do here at this part of the problem? Taryn, what would I do at this part of the problem? Desiree, any ideas? What would I do at this part?
Which part?
Where I'm adding the two together.
Subtract 90.
Not going to subtract 90.
Add 4.
Add 4? No.
Add 8.
No. What about them? What do we call that? Huh?
Like term.
Combining like terms. Yeah. So I've got a 9x plus an 8x, which gives me how many? 17x. And I have negative 8 and negative 4. Make sure you look and see if you have some of those same terms on the same side of the equation. So negative 8 and negative 4 is negative 12 is equal to 90. So add 12, add 12. 12s cancel out. Coming over here, 17 times x is equal to 102. I'm trying to solve for x, so I'm going to divide by 17, and hopefully someone with a calculator. What is 102 divided by 17? Looks like 6. So x is equal to 6, which answers that question. Now it says find the measures of angle K and M. Well, angle K is 9x minus 8. So I'm going to have to substitute that 6 in for the x. So 9 times 6 minus 8 is 54 minus 8, which is, 46? 46 degrees. And I'm going to do the same thing for M. M, as I look over here, is 8x minus 4. Substitute that 6 in place of the x. 8 times 6 minus 4 is 48 minus 4, which is 44 degrees, because we're talking about the angles. Okay? All right. Any questions on that 5, number 5? Yeah.
Would you ever have to actually do the other one?
Do
Or
the,
you just subtract 46 from 90?
you could do that. Absolutely. You wouldn't have to. Very good thinking. Yes. Because they both add up to 90 anyway, right? So if you find one, 90 minus 46 does give you 44. Excellent thinking. Good job. All right, let's take a look at number 6. I don't think we've done 6, have we? given that line segment FG, right here, this line segment, is congruent to line segment JH, what does that mean when I say they're congruent?
They're the same length.
They are the same length. So since we know they're the same length, let's jump down to B. Find the following measures. So what is the length of FG if they are congruent? 6. Yeah. If they're congruent, that means they have the same measure. So they are the same length. And we know that this arc here in green is 143 degrees. If FG and JH are congruent, how could I find the measure of arc JH?
Look at FG.
Look at what?
Look at FG.
Yeah, arc FG is 143, so is arc JH. Because the same length of a line segment cuts off the same part of the circle on the opposite side. Okay? All right. So we ran out of time. I'm hoping I can get through more of this with maybe some of the other classes. So you might check back later. So I am going to say that your homework is to work on your notes sheet. Okay, work on the notes sheet. I'm going to collect it. I'm going to say Monday at the latest. I would really like for you to get the most or the majority of it done tonight, especially those of you that have accommodations. I might need to get you your finals sooner, okay? Because I need to make sure you have enough time to complete them, all right? So work on that. And also, let's work on Module 6, if you have not already. This is the surface area and volume. Let's see. That's right after the circles. So I'm going to say that must be 3, 4, 5, 6. Must start on page 6. So that would be 6, 7, and part of 8. Okay? So page 6 through 8, and work on adding to your notes, okay? As much or as little as you want to put, that is up to you. Okay? Yeah. Let me just cite